Scientific notation, section 1.5. In science, we have very small and very large numbers that are used. Very small numbers, if you think of the size of a virus particle, or you think of the size of a water molecule. Very, very small. Very large numbers. If you think of distances in outer space, very large. If you think of those really small oxygen particles or water molecules in some container, you have a lot of them, a very large number. So you have numbers that are very, very small and very, very large. Things that are on very small microscopic scales, nanoscopic scales, okay, very small, and very large macroscopic scales as well. A concise way to write these numbers is scientific notation. And in scientific notation, you have a coefficient and you have an exponent. The coefficient, you have a decimal written after the first non-zero number. And then you have your power of 10, your exponent, which denotes how many places that decimal was moved to make the number be reported in scientific notation. So what we're going to do in this video is we're going to have numbers that are large and small and put them into scientific notation. To put a number into scientific notation, a simple way to go about doing so is ask yourself the initial question: is the number greater or less than 1? If the number is greater than 1, you're going to move the decimal after the first non-zero digit to form the coefficient, and the number of spaces that the decimal was moved will be the positive exponent. If the number is less than 1, you're going to move the decimal after the first non-zero digit to form the coefficient, same thing. But the number of spaces the decimal was moved is the negative exponent. Let's look at two examples initially. 240,000, clearly greater than 1. We're going to move the decimal after the first non-zero number to form the coefficient. Okay? You say, well, there's no decimal. Well, the decimal is understood to be here. This is a whole number. Decimal is understood to be in that location. So now we will move the decimal after the first non-zero digit. Now, you may look at this and you say, well, what's the first non-zero digit, the first non-zero number? If you were reporting this number to somebody verbally, the first non-zero digit you would say is 2. You would report this number to somebody. If you were on the phone and you couldn't see the person, you would say 240000. The first non-zero digit is the 2. So you're going to move the decimal after that first non-zero number or digit. 1, 2, 3, 4, 5 spaces it was moved. So the coefficient becomes this 2.4, and the power of 10 becomes 10 to the 5th. You moved this decimal 5 spots. 1, 2, 3, 4, 5. Let's look at a number that is clearly less than 1. Okay, so we have a decimal here. Okay, 2400 thousandths, if we were to say it properly. Okay, very, very small number. Again, we want to move the decimal after the first non-zero digit, the first non-zero number. And if you were telling somebody this number, okay, you would say 0.000024. 2 is the first non-zero digit. You're going to move the decimal after that. Switch to red ink here. Keep it consistent. 1, 2, 3, 4, 5. Your coefficient becomes 2.4, and your power of 10 is 10 to the negative 5th. Okay, so the negative exponents mean that we have numbers that are very small, they're less than 1, and a positive exponent lets us know that we have numbers greater than 1. Let's look at some mixed examples and put them into scientific notation. Okay, let's get some practice with putting numbers into scientific notation. I do realize that this may be a review for a fair amount of you, and that's fine. If you learn scientific notation a different way to get the same answer that is correct, that is fine. So I'm just trying to show you a way that, a different way that sometimes works easier for people that may have had trouble with learning the other way. Okay? Look at the number. Is it less than 1 or is it greater than 1? Clearly less than 1. So we want to move the decimal after the first non-zero digit, which is a 1. Okay? 1, 2, 3 spaces. 1.05 times 10 to the negative third centimeters. I gave you numbers with units as measurements to prepare for the next chapter. We're going to be learning about metric units in chapter 2. Okay, so let's say these are numbers that are associated with certain measurements. Okay, we need to put this small number into scientific notation. Okay, the first non-zero digit is a 1. We want to put the decimal after the first non-zero digit. Decimal was moved 3 spaces with the negative exponent of negative 3. All right, let's look at the next one. We have a pretty large amount of mass, 195,000 grams. Okay. Let's look at this and put this into scientific notation. There's no decimal, but the decimal is understood to be right here. 1, 2, 3, 4. Okay. 5. The first non-zero digit is the 1. So you want to have the decimal after the first non-zero digit, 1.95 times 10 to the 5th. 1, 2, 3, 4, 5 grams. Okay. So this is a pretty large mass. All right. Over here we have a volume, 4,500 milliliters. Clearly the number is greater than 1. Decimal is understood to be here. We want to move the decimal after the first non-zero digit, which is a 4. 1, 2, 3 spaces we move it. Coefficient is 4.5. The power of 10 is 10 to the third. The units would be milliliters. Number 4. We have a pretty small number here. Okay, it's a very small volume. We want to put that number into scientific notation. The first non-zero digit is this 9. 1, 2, 3, 4 digits over. Our coefficient becomes 9.90 times 10 to the negative 4th liters. 1, 2, 3, 4. Okay. In your calculator, you have, or on your calculator, you have functions for exponents, for powers of 10, and you could do one of 2 ways. Each calculator is a little bit different with how the exponents are set up. But let's just say I wanted to put this number in my calculator. You could do 1.05. Try to get that glare out of the way. 1.05. I stand here, it's better. And then you can do times 10, up arrow, negative 3, equal. And you get what we initially had here on the board. Okay? That's one way to put a number in the calculator's scientific notation. Another way is use of the exponent key. On this calculator, it's right here, EE. 1.05, you enter in your coefficient, and then you would hit the second EE. That EE key, that exponent key, is equivalent to times 10. And then all you would need to do is put in the negative 3. One or the other. If you use this exponent function, you do not use the 10. You do not use the times 10 because this exponent function is the same as times 10. Okay, and that's a way, there are two ways that you can put numbers in scientific notation into your calculator. When we start to do math problems with numbers in scientific notation, which we will, you want to put the number in parentheses. Okay. So for instance, 1.05, open parenthesis, 1.05, second EE to the negative third, and then close the parenthesis. Okay, equals. Each calculator is a little bit different, so you want to make sure that you can do exponents on whatever calculator you have. This calculator here, the TI-30X, Roman numeral 2S, is very simple to use. When we do logarithms, it's very simple to use. It's very easy to use with exponents. We will be doing a lot of math in this course. Graphing calculators you can enter in very easily as well, and you can see in the display what you've put in. But whatever calculator you have, make sure that you're familiar with it and you're able to do the math on it. Each calculator comes with a little information card, okay, or a booklet, or some online resource, but you want to make sure that you can use your calculator to put exponents in. If anybody has any questions about their calculator and would like me to help them out with their calculator, just let me know. Okay, this concludes chapter 1. Next video lecture will be chapter 2.